Now for some key knowledge. Have you revised this topic yet? Key rules. In the aqueous solution, water molecules break down, producing hydrogen ions, H+, and hydroxide ions, OH-, that are discharged. At the positive electrode, oxygen is produced unless the solution contains halide ions when the halogen is produced. At the negative electrode, hydrogen is produced if the metal is more reactive than hydrogen. Worked example 1. Lot of information to read here, so you could pause the video and read through first. Question A. Explain why the colour changed at the positive electrode. So what I should know is that the opposite is going to be attracted. Looking at the question, I have got a yellow coloured chromate ion as a negative ion. So chromate ions are attracted to the positive electrode. And why? Why? Because opposite charges attract. 2 marks. Part B. The gas produced at the positive electrode was oxygen. The oxygen was produced from hydroxide ions. Name the substance in the solution that provides hydroxide ions. Hydroxide ions are found in aqueous solutions. Aqueous solutions are water. Let's take a look at the GCSE mark scheme. So for A, chromate ions moved to the positive electrode, 1 mark, because opposite charges attract, 2 marks. And for B, it was water. Hydroxide ions are found in water. Worked example 1, part C. Describe how the solid forms at the negative electrode. So we know that positives are attracted to negatives, so the positive charge will be attracted to the negative electrode. So the copper ions will attract to the negative electrode and gain 2 electrons. And as the copper ions gain 2 electrons, copper atoms will form. That answer will gain you 3 marks. Part D. The student repeated the investigation using potassium iodide solution instead of copper chromate solution. Name the product at each electrode when the potassium iodide solution is electrolyzed. So looking at this, I know that potassium is higher in the reactivity series than hydrogen. So hydrogen is going to be discharged because of that. And I know that iodide is iodine, so that's a halogen. So iodine is going to be discharged. Let's put that into the answer. At the negative electrode, so positive is attract, so that is going to be the hydrogen. And at the positive electrode, that is going to be iodine. Check against the GCSE mark scheme. So for part C, copper ions gain 2 electrons. That was for 2 marks. And copper atoms are formed. For D, at the negative electrode, we have got hydrogen forming, and at the positive electrode, iodine. Worked example 2. Again, lots of information provided. Maybe take a pause and have a look at the information. Part 1, explain why magnesium chloride must be molten or dissolved in water to be electrolyzed. We know that ions need to move. So that ions can move. Where are they going? To the electrodes. And what they carry in? A charge. Guaranteed 2 marks. Part 2, explain how magnesium is produced at the negative electrode in experiment 1. Experiment 1, we're dealing with a molten substance. Magnesium would form a 2+ ion. So magnesium ions are attracted. Okay, so they're attracted to the negative electrode. What happens there? They gain 2 electrons. And what do they form? Forming magnesium atoms. So let's take a look at the GCSE mark scheme. For part 1, we had to talk about the ions moving to the electrodes or say that they carry a charge. Part 2, magnesium, didn't need to say ions this time, that's why it's in brackets. Attracted, didn't need to say to the electrode, it's in bracket. So magnesiums gain electrons, and you had to say that they gained 2 electrons. Time for a question. Your turn. Time for some practice. Okay, we've got another 3 parts to the question here. I've provided the diagram. Pause the video and have a go at parts 3, 4 and 5. These questions are focusing on experiment 2. Experiment 2 involves an aqueous solution, magnesium chloride dissolved in water. I know that magnesium is more reactive than hydrogen, so hydrogen is going to be formed. Part 4, suggest why magnesium is not produced at the negative electrode in experiment 2. I have just stated that magnesium is more reactive than hydrogen, and so therefore hydrogen is discharged. And then finally, we've got a half equation. There is another video on half equations available to you, but for this one, Let's balance out first. So this would be 2 and this would be 2E minus. Let's take a look at the GCSE mark scheme. So the gas was hydrogen. Part 4, magnesium is more reactive than hydrogen. And there is the completed half equation. How did you do?